To determine if our clamping methods for both the first and second operations were sufficient, tangential cutting force calculations were completed using a safety factor of 2.0. As discussed in lecture, tangential forces during cutting are significantly higher than longitudinal and radial forces in most cases. Knowing this, calculations for worst-case scenario during cutting were completed to determine if the fixture would securely retain the workpiece during the most extreme cuts. After analyzing all cutting operations in the first and second machining operations, it was found that the rough contouring of the raw stock provided the highest cutting forces. A maximum cutting force of 329 pounds was calculated using the required safety factor, proving that the clamping methods were sufficient for both operations. The raw stock in Operation 1 is held in place by two Mighty Bite original fixture clamps that press the stock against a pin and a ground locating rail. Each clamp holds at a maximum of 800 pounds. The tool that provided the highest cutting force in this operation was the half-inch end mill that completed the roughing of the workpiece contour. As mentioned previously, the highest force during this cut is 329 pounds. To determine the effects of this cut on the stock, a basic finite element model was completed using these parameters: the material properties of the 6061 T6 aluminum, and the tool feeds, speeds, and chip loads of the aforementioned roughing operation. A basic finite element model of the raw stock was created using an absolute worst case, representing a scenario that is highly unlikely to occur during actual cutting. The FEA model here shows the location of the two clamps and their corresponding forces on the front side, the reaction force from the ground rail on the back side, and a slight pressure force from the pin on one of the other sides. A fine mesh was created of the whole piece, and the forces from the cutter were placed at the farthest lever arm from the clamps themselves on one of the far corners of the stock. Analysis was completed using these forces and the mesh to determine stress and deformations that would occur during cutting on the part itself. We analyzed the deformations that are possible due to the cutting and clamping forces in the part. Seen here, maximum possible deformations under the worst case scenario modeling we completed remain under 3/10,000ths of an inch. Shown here are the von Mises stresses calculated by the SOLIDWORKS simulation tool. The highest stress in the part is still lower than the yield strength using the absolute worst case scenario, showing that yield or plastic deformation will not occur during cutting. Both the stress and deformations are safe working parameters and will not adversely affect the material itself or the tolerances in the geometric relationships of the final part.